Hello, welcome to class. This is another section of the topic we started before now under electrolysis. Before now, we have discussed what electrolytes are. Compounds you will regard as electrolytes. Today, we shall be looking at another segment, which is electrodes, or two segments, electrodes and the electrolytic cell. Electrodes and electrolytic cell. The topic electrolysis is not something you just talk about just like that. Students will get confused. So we'll take them one at a time. Having discussed that electrolyte, we want to look at electrodes and the electrolytic cell. We said in our previous class that electrolytes allow current to pass through them in their aqueous form and in their molten form. Right? Yes. The ionic compounds. You will notice that in our previous class, sodium chloride, which is ionic compound, appeared in two different options. One is in solid, the other one is in aqueous. That one that is in solid is not an electrolyte because it will not have mobile electrons. It's mobile ions. The ions will be intact. But the aqueous one means that the sodium chloride, which is ionic compound, has been dissolved in water and the ions will be moving. Now, how do we study this movement? The movement of these ions or current passing through. That is why we want to look at what electrodes are today, and then what is called electrolytic cell. I'm going to draw it on the board. If I have a container, just watch what I am doing. It's very simple. If I have a container, this is a container. Inside this container, I have that ionic compound that has been melted or that has been what? Dissolved in water. Permit me to use sodium chloride. If I have sodium chloride here, which is what? In aqueous, sodium chloride, aqueous, AQ, what does that mean? That means that the sodium chloride has been dissolved in water. So the ions here, which are sodium ion, positive, and the chloride ion, negative, are in mobile phase now. They can move. So any current that's passing from one point to the other can have a free access. Okay, that is it. Now, where will this current come from? Which direction will the current enter? And which direction will the current leave? That will take us to the term electrodes. Electrodes. I'm going to draw two things here. Now, those two things are electrode. Watch me. I want to draw something like a rod. This is the rod. This is another rod. How many rods do I have? I have two. This rod, two of them are connected to a current source. So if I have my current source to be here, and is connected to this particular rod, I have another current source, the same point anyway, connected to this particular rod. What is happening now? This is the positive form of this rod, and this one is the negative. These two rods that are here are serving the same purpose. The same purpose in the sense that Current will enter inside this electrolytic cell through one of them, and finally leaves from one of the what? Rods. We have two rods there, the positive one and the negative one. So these two rods, two of them, these two rods are called electrodes, are called electrodes, are called electrodes. The two rods are called electrodes. What is the function of each of these rods? Current enters into the cell, into the electrolytic cell through one of them. And current leaves from the electrolytic cell inside this place through the other. Now, if you don't want to explain it in terms of current or conventional current, you use the flow of electron. So, in other words, electron moves into the cell, into the electrolytic cell, through one of them, and also leave from the same cell through the other rod. These two rods are called electrodes, are called electrodes. Can we then define electrodes? Can we then define electrode? What are electrodes? Having explained that the two rods, and having told you the function, the major function of these two rods, what do you think is the best definition for this? Now, electrodes are conductors, or they are conductors in the form of wire, in the form of rod, that allow current to enter or leave an electrolyte from the electrolytic cell. They are conductors in the form of rod or wire that allow electric current to enter or leave an electrolyte from the electrolytic cell. Look at them, these two rods here. Current enters through the positive part and then leaves through the negative rod. What is the name given to the positive rod, the positive electrode? The positive electrode is called the anode. It's called the anode. The positive is called the what? The anode. Through which the conventional current enters the what? Electrolyte in the electrolytic cell. While the negative rod or negative electrode is called the cathode. The current finally will move out from this electrolyte inside the electrolytic cell through the what? Negative electrode called the what? Cathode. If you don't want to define it using conventional current, you can use electrons. So we can define electrodes are conductors in the form of rod or wire through which electrons enter in the electrolytic cell or leave from the electrolytic cell. Now, in terms of conventional current will enter into this particular place through the anode, positive, and the leaves through the what? Cathode, negative. But electron, using electron now, it will be the opposite. The flow of electron moves out from the anode and then enter into the electrolytic cell through the what? Cathode. Take note, because exam like WAEC and IGCS, the exam like IGCS will ask you to draw the arrow showing the flow, the direction of electron. The direction of electron should flow from the anode, from the positive. So if I should draw the arrow showing the direction or the movement of electron, it's going to be from this anode. Okay? The direction will be like this. That is the arrow. It moves like this. Okay? Then the electron enters in the electrolytic cell or in the electrolyte, which is inside the electrolytic cell, through the what? Through the what? Cathode. So the direction of the electrons continue this way. This is opposite of conventional current. Conventional current enters in the electrolytic cell through the anode and then finally leaves through the cathode. While the electrons moves outward through the what? Anode. So be careful when you are faced with such questions. Okay. The points you must note here are, two of them are medium through which whether conventional current or electron will enter the electrolyte in the electrolytic cell or leave the electrolyte from the electrolytic cell. You should also note that the positive electrode is called the anode, while the negative electrode is called the cathode. Now, we have done oxidation and reduction reaction. If you remember, we discussed oxidation reaction as what? A reaction where there is a loss of electron, where electron moves out. So since we said at the anode, electron move out from the anode, as I have already shown you in the diagram here, that is the flow of electron. That means the major reaction that occurs at the anode, this is the anode. This is the anode, while this negative one is the what? Cathode. So here there is loss of electron. Electron moves out through the anode. And loss of electron is oxidation reaction. That means the major reaction that occurs at the anode is what? Oxidation what? Reaction. Oxidation reaction. Okay? Oxidation reaction. This is aqueous sodium chloride. Oxidation reaction. So anode, which is the positive electrode, reaction that occurs there is what? Oxidation. Why? Oxidation is a loss of what? Electron. And here, electron is being lost. Look at the flow. Look at the flow. Look at the movement. The movement of the electron, look at this. Look at the direction. Why the conventional current enters in and leaves here. Why the movement of electrons is from here and then finally enters into the electrolytic cell through the what? Cathode. Okay. Since electron now enters into the electrolytic cell through the cathode, that means the cathode is actually accepting electron. Okay? And in our previous class, where we discussed oxidation and reduction, we said that reduction reaction is what? Gain of electron. A substance gaining electron is a reduction reaction. Therefore, the reaction that occurs at the cathode is what? Reduction reaction. Reduction reaction. Why? Because there is what? Gain of electron. The cathode, which is the negative electrode, is actually accepting the flow of electron that's coming there because it is through this medium the electron flows in. While the anode, the electron is moving out from there. So that means that oxidation reaction is actually taking place in the anode. Take note, whether in the electrolytic cell or in the electrochemical cell, because we will soon discuss electrochemical cell. We are talking about electrolytic cell now. Both of them, the reaction that occurs at the anode is oxidation because there is always flow of electron moving out from there. That means that particular rod or conductor or whatever is actually losing an electron. We still correspond with our previous knowledge under oxidation reaction and reduction reaction. Is that okay? Now, why that of the cathode? Why that of the cathode, which is the another rod but negative, where electrons enter? What does that state? It simply it's telling us that this particular electron which is negative is what? Taking in that electron. Because through there, the electrons will move inside this electrolytic cell. So reduction occurs at the what? Cathode. While oxidation occurs at the what? Anode. Have you seen it? So this concept you must understand. You have understood what electrolytes are. I am not discussing with you what electrodes and the electrolytic cell are. We are done with electrodes. Now, watch what I have drawn here. This setup is called electrolytic cell. Look at it. This setup you have seen here now is called electrolytic cell. This is the assembly of the two electrodes and the electrolyte. When you assemble all of them connected to a power source, that is electrolytic cell. But what definition will you give in an external exam where you are asked to define electrolytic cell? I want you to define it with the function. What is actually happening in the system? What is happening? When this current is coming through this point and enters here, right? At the end of the process, chemicals are produced, which we are going to discuss in the next segment, where we'll be analyzing, where we shall be showing what is happening during electrolysis. You will discover that as the current is passing through this electrolyte here, the electrolyte itself gets decomposed. And after the whole process, after the whole chemical reaction, you will discover that new chemicals are deposited in the various electrodes. And even inside the electrolytic cell, there are new chemicals that will be formed. Although in some occasion, the electrolytes will remain the same. The chemical inside may remain the same. But usually, they are decomposed. The compound called ionic compound, called electrolyte, inside this particular cell will be decomposed as current is passing through them. So, what will you call a cell that actually converts electrical energy, that is current coming through this place, and finally producing a chemical, which is what? Another substance altogether. What will you call such cell? Such cell is a cell that converts electrical energy to chemical what? Energy. So this is the definition you give when you are asked what is what? An electrolytic cell. It is a cell that converts electrical energy to what? Chemical energy. They convert electrical energy to chemical energy. How does this happen? How can it be achieved? It can only be achieved after the process has taken place, which is electrolysis. Now, how can we achieve this? We are going to achieve this by analyzing what happens during the passage of this current. What actually happens to the compound here during the passage of what? Current. Can you see it? On our slide, we have the electrolysis. It's a device where electrolysis occurs using electrical what? Energy. Using electrical what? Energy. Where electrolysis occurs using electrical energy. Then what happens? The electrical energy is being converted to what? Chemical energy. Because at the end of the process, chemicals are produced either in the form of compound inside the electrolytic cell or in the form of elements, neutral elements at the various electrode. Okay? At the various electrode. Okay, that will now take us to electrolysis. Electrolysis. After explaining what electrolysis is, we shall take various examples or what happened during this process. So far we have understood what electrolytes are. Where can we find this electrolyte in a setup? We find it inside an electrolytic cell. What are these electrolytes? They are ionic compounds that are in the form of molten or aqueous state. They are placed into an electrolytic cell where current can pass through them. And this current can enter into the cell through one of the electrodes called anode, positive, and they then leave the cell through another form of the rod or electrode called what? Cathode. We want to look at how this process can take place. That will take us to this section of this topic called electrolysis. You have understood electrolytes. You have understood electrodes. You have also understood what an electrolytic cell is. So what is electrolysis now? What is now electrolysis? Electrolysis. I don't want you to cram. I want you to understand it. That process by which current is passing through an electrolyte inside this place is called electrolysis. So we are now going to put one or two things that happen so that we can have a better definition. As the current is passing through, whatever compound that is here that is ionic will get decomposed. It's a chemical decomposition. Okay? It's not decomposing maybe because it's decaying, no. So, there is a decomposition. But what type of decomposition? Chemical what? Decomposition. So can we now have the definition? Electrolysis is the chemical decomposition of an ionic compound. What is that ionic compound? Electrolyte, right? Which is here. By the passage of electric current. Don't forget. Current, this is the source of current. Right? That is the source of the current. As the current is passing through a compound here called sodium chloride, right? The current will enter and finally leaves. Before the current leaves, the compound here, which is an ionic compound, is decomposed. Will no longer remain the same. So this chemical decomposition of this compound, because of the passage of electric current, is called electrolysis. Electrolysis is the chemical decomposition of what? Ionic compound, in brackets, electrolyte, by the passage of electric current, or using electric what? Current. Or somebody will say, it is a process by which an electrolyte in the electrolytic cell is decomposed due to the passage of current. You are still correct. Because that decomposition is actually what? A chemical one. How does it happen? Because current has to pass through it. Current, get this right, because if you understand this part, the next aspect of this topic, when we shall be dealing with various electrolytes, the analysis of various electrolytes, their electrolysis, you will not find it difficult. What will happen to this compound which is being decomposed because currents actually pass through? They have to separate into ions. Remember, originally we have said the compound contains two parts, positive ion and negative ion. The moment currents start passing through this compound inside this particular cell, the compound decomposes. The compound will be in the form of ions, positive and what? Negative. Take note of that. What will happen to two of them? The positive one will look for where it will, have access to a negative charged something so that it can be neutralized. Okay? While the negative one will look for positive. What am I trying to say? Remember, we have two rods. One is negative, one is positive. So the ions inside this electrolytic cell, the positive one will move to the what? Negative. While the negative ion move to the what? Positive electrode. I'll take time here to explain this. Please pay attention. Pay attention. Students confuse cation and the cathode. They confuse anions and the anode. They are not the same. The cation and the anion both have to do with charged atoms that have gained electrons or lost electrons. That has to do with positive charge and negative charge. But when you mention cathode ending in ode and anode ending in ode, you are talking about conducting wire or rod through which current enters in the electrolytic cell and the other one current leaves the electrolytic cell. When electrolysis is taking place, when current is passing through and the compound here separates into ions, positive and negative. It must be positive and negative because originally I have told you that the compound here is an ionic compound. So it contains ions. It contains positive side and negative. So the positive ions now, we start looking up to these two rods. Which one is negative? That is where it will go as in opposite to neutralize. While the negative ions here will look for the positive electrode where it will go. Understood? Positive ions move to the negative electrode. Why negative ion move to the what? Positive electrode. I repeat. Positive ion in the electrolytic cell, positive ion, move to the negative electrode. What is negative electrode? Cathode. Why negative ion inside the electrolytic cell will move to the positive electrode, which is what? Anode. Then something will happen, which is what I will explain now. How electrolysis works. Look at it. Electric current causes what? Cations, which is positive, to move to the what? Cathode, which is the what? Rod. The negative rod. And then what will happen there? When it gets there, it will gain electron and produce a neutral element. And produce a neutral element. Cations, what is cations? Positive what? Ions. Where will it move to? It moves to the what? Negative electrode, which is the cathode. And when it gets there, what will happen? It will do what? Gain electron, which is reduction reaction, and produce a neutral atom. Now, I am still using sodium chloride. Please pay attention to this. I am using sodium chloride as a case study. Watch. Assuming I have sodium chloride here. What are the two ions I have here? I have sodium plus and I have chloride minus. So, what is my cation here? My cation is what? Sodium plus. It's plus. So between the two electrodes, where do you think this positive ion should go to? it should go to the opposite, which is what? Negative, cathode. Watch. See what happens. Now, I said there are two ions here. Imagine this setup, you have this setup and current start passing through, enters inside here where we have sodium chloride. The sodium chloride, because it is in aqueous state, the ions are already mobile, right? So I have sodium ion, which is part of them, part of it, and I have chloride ion. So which one is positive? Positive here is sodium ion. It must migrate to either the positive electrode or negative, the two rods. So what is the rule? The rule says that it will go to the one that carries opposite charge. Here, the ion itself is having positive, so it should go to the negative rod. What is the name of the negative rod? Cathode. Getting to the cathode, it will accept electron. That's why we said at the cathode, what happens there is addition of electron, gain of electron. And gain of electron in terms of oxidation and reduction is what? Reduction reaction. So what will happen? One plus and one negative, what will happen? You have what? Neutral what? Sodium. So here is coming from the aqueous one. Okay, after getting an electron, what do you have here now? You have a neutral atom, which is now solid. So this sodium now is being deposited at this rod as a chemical of its own and is collected. That's why I said in the definition of electrolysis that it is a what? Chemical decomposition of what? An electrolyte or ionic compound due to the passage of what? Current. Then the question is, what happened there? Which actually helped us to define an electrolytic cell. I say what happened here is that electrical energy is being converted to chemical energy. And I said that chemical can be an element, just like what has happened now. After this reaction, sodium as an element, which is a chemical, gets itself deposited at the what? At the cathode. So this is actually happening at the what? Cathode. So we call it what? Cathodic half reaction. The equation is cathodic half equation. So if you are asked in the electrolysis of aqueous sodium chloride, show the reaction that occurs at the cathode. What do? Cathode, you write cathode. Cathodic half equation, or at the cathode, what happens? What will come to the cathode is what? That which has opposite charge of the cathode. The question is, what is the charge of the cathode? Negative. So which ion should come to it? The positive ion. Now, between the sodium ion and the chloride ion, which one is the positive? Sodium. That means sodium ion will go to the cathode. So in order to neutralize this, you have to do what? Balance it using an electron. Remember our electrolysis, our reduction and oxidation reaction. So we are going to balance this by electron. I have electron here, adding of electron. How many electrons? 1. If I have 2 here, I will use 2 electrons to balance it. So finally, what will I have? I will now have what? Neutral what? Sodium. So this sodium now is solid. But the sodium ion actually came out from here, from the aqueous form of sodium chloride. So here we'll take the what? Symbol of what? Or the state of matter of what? Aqueous. Where will you see this now at the end of this electrolysis? It is being deposited at this rod, which is the what? Cathode, and is collected as a chemical. That is why electrolytic cell is defined as that cell that converts electrical energy to chemical what? Energy. Finally, on this particular segment, we shall now look at what happens at the anode. At the anode, what do you think that will happen at the anode? Watch it. At the anode. Anode is the positive. So anode is expecting to get a positive charge. So between this sodium and chlorine, or sodium ion and chloride ion, the one that is negative is what? Chloride ion. So the chloride ion will move to the anode. So chloride ion, which is negative, will move to the what? Anode. what will happen? How do you balance it to get a neutral chlorine atom? You cannot put electron where the negative is because electron itself is carrying negative. What do? You draw your arrow, meaning that it will be losing electron. Have you seen it now? Why the previous one we did was plus electron, gain of electron. So I have loss of what? Electron. For electron to be lost, one electron, you now produce what? Chlorine atom plus an electron. So this minus will take care of this minus, and the chlorine atom is produced. But chlorine, being a molecule, does not like to stay in this form, which will appear as a what? A molecule. That is Cl2. So for you to balance this, you have Cl minus to give you Cl2. For you to get Cl2 means that the atom must be balanced by putting 2 here, and means that the charge is now what? Minus 2. So to balance it, you add 2 at the back of what? Electron. So this is what happens in the process called electrolysis. We shall move into the next section where we'll pick up to 4 to 5, 6 electrolytes and analyze what happens at the cathode and the anode. Then at the end of that, we are going to have questions we shall answer in order to know or find out if we have actually understood this topic. Till then, thank you.